week 3 is RAG, Retrieval Augmented Generation, and it's a RAG Foundations week. Basically, what I love about the AI space is that it evolves all the time. Maybe a bit too fast, but still. And if you remember, maybe 2 years ago, the hot thing was fine-tuning your LLMs, getting a pre-trained model and then adjusting the model weights in some, parameter efficient fine-tuning or some other way, LoRa, QLoRa, other things, to get it to understand your domain knowledge, your business context, or your specific business data and speak in your business language. I feel that the world is shifting away from that and more towards, so that is like, what is that? That is training time customization. I feel the world's shifting away from that towards inference time customization, which is more around RAG, right? You keep the LLM intact, you don't fine tune it because that is costly, and LLMs, these companies release them very often, very frequently. And even if they don't release them, you might want to change from OpenAI to Anthropic or some other LLM, right? So if you keep fine-tuning, or you can't really fine-tune some of them, right? Because they're closed source. So if you'd be using something like a Llama model, and but what if you want to change later on? So there's lots of constraints. So what the world's moving towards is inference time customization, which is mostly retrieval augmented generation, RAG. So you can, without changing the underlying weights of the large language model, you just add data to it through a vector database, through RAG, and it can pull data directly from documents that are relevant to your business, to your industry, and things like that. And so that's why RAG is powerful. It's very important for an AI engineer to know RAG. And in this week, I guess let's talk a bit about what the participants learned. So building for your DIY bootcamp, build a full retrieval augmented generation pipeline from scratch. Learn about chunking, embeddings, vector databases, and retrieval chains. Do some research about hierarchical RAG. So why it outperforms flat retrieval. Hierarchical RAG is when you have, it's kind of in the name. You have hierarchies of your documents, and then when the LLM needs to find something, it first uses that vector database to find the top layer, where would that information be, then from there go drill further into the specific document, then in specific page or whatever else.
So that could maybe be something like, if you had legal documents, the high level could be the whole document, and then you could, like, at a level deeper in the hierarchy, it could be all the clauses in a document.
Yep.
And then a level deeper, you could have all of the sentences in a clause.
Yeah. Or even you could even have an even higher level, like if you have legal documents, HR policies in your company, you have, I don't know, maybe it's a tech-heavy or asset-heavy industry, so you have descriptions of your different assets or your procurement documents, suppliers, and so on. So where does it go in the first place, right? Like, is this a question about a legal term, or is this a question about how we procure things, or is it a question about HR policies, and drills down further like that? So can be definitely very powerful. The tools that we recommend for week 3 are OpenAI embeddings, Chroma databases, LangChain retriever. So a lot of the work we did was, or the participants did, was around using LangChain, and the Chroma database is a simple to set up database. You could be using some AWS OpenSearch, or which used to be called Elasticsearch, but Chroma database was the choice because it's just, you spend less time thinking through how to set it up and more on how you're using it. The pro tip here is really interesting. Smart chunking improves performance. So overlap, think about when you're chunking your data for retrieval for vector databases, think about overlap and also semantic clarity and context-aware chunking. That's probably my favorite part, that you can chunk like your data when you're putting into a vector store, let's say 500 characters or 500 tokens per chunk, but then you might end up with situations where like something's split in the middle, right? Like you're like a certain HR policies like split right in the middle. You could chunk by section of your document. You could make your chunks overlap, but also context-aware chunking is the art of putting these things into your vector store, because remember that embedding models are shallow, and they can miss certain things. So you need to I'm just trying to find an example here. If you're looking for some information on like I think the example in the bootcamp was who won the last year's Employee of the Year award. And that is in some HR document. But then if the chunking like cuts it in half, the Employee Award of the Year was awarded to, and then the name is in the next chunk, then it might not be able to find it. So yeah, smart chunking can really affect the effectiveness of your RAG.